And welcome back to the channel, everyone. Today we're going to talk about a little bit more in depth the distributive property and now some more challenging problems. And I'm going to throw some variables at you, see how you operate. Okay. Process stays the same. So we are still going to distribute our factor out here, this 8g, and we're going to still multiply it by both terms inside our parentheses in that quantity. So here I have 8g times the quantity of 4k minus 2. That's how we say it in our class. But again, we want to make sure that we keep implying this quantity implies we have parentheses here. Okay? So I digress. Now, let's actually multiply through. Well, we know that we can multiply 8 times 4. The coefficients, we can multiply them together to get 32. That's our new product. And now we have this g times k piece. Okay? Well, understood in multiplication, technically here, 8 times g is 8g. It's understood that it's multiplication. Same thing here with the 4k. It's 4 times k. So if we can't actually compute it or make it simpler, we actually just place the variable right next to the coefficient. The same is true when multiplying with variables. G times k, the only thing I can look for is if I had two terms which are identical here, like x times x, we know is going to create an x squared. But I can't do anything with x times y. If I have x times y, just left with xy. So I'm just going to do the same thing here with g times k. It just becomes gk. There's no other way to express it. Okay? Then I take my second term, 8 times negative 2 becomes negative 16. And because there's still that g there, times g would just be negative 16g. Now I know sometimes we get confused. Can I combine these two, although they both have a g? Well, yes, they both have a g, but are there variables identical here on the back end? And if they're not, they are not like terms. We cannot combine them. So in reality, this is your final solution. One more here. Now we're going to look and see what happens if I have some exponential pieces here. So I have negative 3y times the quantity 2y minus 7x. I'm going to distribute that in here. Negative 3 times that positive 2y. Okay, so negative 3 times 2 becomes negative 6. I do have y times y, which ends up being y squared. And I finish this off. Negative 3 times, again, this is where we always make our mistakes. We want to be very particular here, very specific. Negative times a negative equals a positive, and then 3 times 7 is 21. And then y times x, well, I don't have that y times y situation, so I'm just left with xy. Again, you look and see, can you combine in this case, which I have a y squared and then an xy, those are not like terms. You are done.